Hi there. Thanks for joining us today. We are looking for a mid-level Angular developer to join our feature team, and based on your profile, it looks like you have about 3 years of experience in the ecosystem. To start things off, maybe you could just give me a quick overview of your experience and what your typical day-to-day looks like in your current role.
Thanks for having me. Yes, I have been working with Angular for about 3 years now. In my current role, I am responsible for owning specific feature modules from the design phase through to deployment. My day-to-day usually involves a mix of building out new UI components, coordinating with the backend team on API contracts, and spending a good chunk of time optimizing our existing state management. I try to take a lot of ownership over the features I work on, so I don't just write the code. I also handle the unit testing and make sure the components are performant and accessible.
That sounds like a solid foundation. I want to dive straight into the technical side. Let's start with something fundamental. For someone who might be newer to the team, how would you explain the purpose of the ngModule decorator and what it typically defines in an Angular application?
Sure, I like to think of the ngModule decorator as a way of organizing the application into cohesive blocks of functionality. Essentially, it is a container that tells Angular how to group related components, directives, pipes, and services. Without ngModules, Angular wouldn't know which components are available to be used in other parts of the app, or which external dependencies are required for a specific set of features to work. Within the decorator, you define things like declarations for your components, imports for other modules you need, and providers for your services. This structure is actually what makes features like lazy loading possible, because you can define a module for a specific route and only load that entire container when the user actually navigates to that section of the app, which really helps with the initial load time.
Right, lazy loading is definitely a key part of our architecture. Speaking of components, we use a lot of them. Could you tell me which decorator is used to define a component and what kind of metadata it usually holds?
That would be the component decorator. It is placed right above the class definition to signal to Angular that this class isn't just a regular TypeScript class, but a component that manages a piece of the UI. The metadata inside that decorator is where you define the essential configuration. For example, you have the selector, which is the custom HTML tag you use to place the component in a template. Then you have the template URL or the inline template for the HTML, and the style URLs for the CSS. It basically bridges the gap between the logic in the TypeScript class and the actual visual representation in the browser.
Okay, let's move into some logic. We have a few screens in our app that display very large lists of data that update frequently via WebSockets. If you noticed that the UI was lagging or stuttering during these updates, how would you go about optimizing that component's rendering performance?
That is a common challenge with large lists. The first thing I would implement is the trackBy function within the ng for directive. By default, when the data array changes, Angular's default behavior is to tear down the entire DOM list and rebuild it from scratch, even if only one item in a list of 1,000 changed. By providing a trackBy function, usually returning a unique ID from the data, I can tell Angular to only re-render the specific element that actually changed. This drastically reduces DOM manipulations. If that still isn't enough, I would look at the change detection strategy. I'd switch the component from the default strategy to onPush. This tells Angular not to check this component for changes unless an input property is updated or an event is explicitly triggered within the component. It stops the framework from wasting cycles, checking a massive list every time something unrelated happens elsewhere in the app. Finally, if the list is truly massive, I wouldn't render all those items at once. I would use virtual scrolling from the Angular CDK. Virtual scrolling only renders the items that are currently visible in the viewport, plus a small buffer. As the user scrolls, the DOM elements are recycled. This keeps the number of elements in the DOM constant regardless of whether the list has 10 items or 10,000.
You mentioned change detection. You touched on OnPush, but could you explain the general change detection mechanism in Angular? Specifically, why is the default behavior sometimes inefficient?
Angular's change detection is the mechanism that ensures the view stays in sync with the model. By default, it uses a strategy often referred to as check always. Whenever an event occurs, like a click, a timer finishing, or an HTTP response coming back, Angular runs a check from the root component all the way down through every single child component in the tray. In a small app, this is imperceptible, but in a large-scale enterprise application, you might have hundreds of components. Having Angular scan the entire tree for every single mouse click or keystroke is incredibly inefficient because the vast majority of those components haven't changed. That is where the performance lag comes from, and why moving to OnPush for leaf components or large data grids is so critical.
That makes total sense. Let's pivot to data handling. Most of our app relies on API calls. How do you typically handle asynchronous operations in Angular, and what are your best practices for managing those streams?
I use the HTTP client service, which is the standard way to handle HTTP requests in Angular. What is great about HTTP client is that it returns observables rather than promises. I treat these as streams of data. To actually get the data, I have to subscribe to that observable. In terms of best practices, I try to avoid manual subscriptions in the TypeScript class whenever possible. Instead, I prefer using the async pipe in the HTML template. The async pipe is powerful because it automatically subscribes to the observable when the component is initialized, and more importantly, it automatically unsubscribes when the component is destroyed. This removes the risk of memory leaks and keeps the component code much cleaner. If I do need to manipulate the data before it hits the UI, I use RxJS Operators. For example, I might use map to transform the response, or catchError to handle API failures gracefully without crashing the UI.
You mentioned memory leaks and unsubscribing. That leads me to the lifecycle hooks. What is the purpose of the onDestroy hook, and what exactly are you cleaning up in there?
onDestroy is the final lifecycle hook that runs right before Angular removes a component or directive from the DOM. Its primary purpose is cleanup. If you have started a process that persists outside the component's immediate rendering cycle, it will keep running even after the component is gone if you don't stop it. This includes things like manual subscriptions to observables, active set interval or set timeout timers, or open WebSocket connections. If I manually subscribe to a service in ngOnInit, that subscription stays active in memory. If the user navigates back and forth to that page 10 times, I end up with 10 active subscriptions all trying to update a component that no longer exists. That is a classic memory leak that will slow down the browser and cause very strange bugs. In onDestroy, I make sure to call unsubscribe on all those handles.
I've seen some developers use a subject with a takeUntil operator to handle multiple subscriptions at once. Have you used that pattern?
Yes, I actually prefer that pattern when a component has more than 2 or 3 subscriptions. Instead of creating 5 different subscription variables and calling unsubscribe on each one, I create a single private subject, usually called $, and I call next and complete on it. Inside the onDestroy hook, then for every observable I subscribe to, I add the takeUntil this destroy operator. It is much more scalable and reduces the boilerplate code in the cleanup phase.
Let's talk about state management. This is where things can get messy. Suppose you have multiple services in your app. How do you ensure proper encapsulation and avoid state conflicts where one component accidentally overwrites data that another component is relying on?
The key there is following the single responsibility principle and strictly controlling how data is modified. I avoid making state variables public. If a service has a piece of state, I make it a private variable, like a private behavior subject. To let components see that data, I expose it as a read-only observable using the asObservable method. This creates a one-way data flow. Components can listen to the data and react to it, but they cannot reach into the service and manually change the value. If a component needs to update the state, it must call a specific public method on the service, like updateUsername. Inside that method, the service can perform validation or logic before actually updating the private state. If the application grows to a point where services are starting to conflict, I would suggest a more formal state management pattern or an orchestration service. This is a service whose only job is to coordinate communication between other specialized services, ensuring that data flows in a predictable direction.
You mentioned BehaviorSubject. I want to dig into RxJS for a bit. Could you explain the difference between a standard subject and a behavior subject? In what specific scenario would you choose a behavior subject over a subject?
I like to use an analogy for this. A standard subject is like a live radio broadcast. If you tune in at 10:00 a.m., you hear everything that happens from 10:00 a.m. onwards, but you have no idea what was broadcast at 9:00 a.m. If a component subscribes to a subject after a value has been omitted, it misses that value entirely. A behavior subject, on the other hand, is like a recording that always keeps the most recent frame. It requires an initial value upon instantiation, and it always remembers the last value omitted. When a new component subscribes to a behavior subject, it immediately receives the current value, even if that value was sent long before the component was even created. I would choose a behavior subject whenever I am managing state that represents a current value, like the currently logged-in user, a theme preference, or the current filter settings for a list. You want the component to have that data the instant it loads, rather than waiting for the next single update to happen.
That's a clear distinction. Let's apply that to a real-world architectural problem. Imagine we have component A, which needs some data. This data is produced by component B. However, component B is only displayed transiently inside a module. When the user finishes in the module and closes it, component B is destroyed. What architectural pattern would you use to ensure component A gets that data reliably without losing it when the module closes?
Since component B is transient, any state stored inside it is gone the moment the module closes. You cannot rely on component-to-component communication like at input or at output here, because the lifecycle of the module is too short and disconnected. The best approach here is to use a shared service acting as a state store, specifically using a behavior subject. Component B, before it is destroyed, pushes the final result into the service's behavior subject. Because the service is a singleton provided at the root level, it exists independently of the module's lifecycle. Component A is subscribed to that same behavior subject in the service, even if component A subscribed before the module opened, or if it's just waiting for the result, it will receive the latest value the moment component B pushes it. This decouples the data from the UI lifecycle and ensures total data integrity.
I like that approach. It's clean and scalable. Now let's shift gears to forms. We use both template-driven and reactive forms. When you are building a complex form with lots of dynamic fields and validation, why would you choose form group and reactive forms over the template-driven approach?
For complex forms, reactive forms are definitely the way to go. The main advantage is that the form logic is moved out of the HTML template and into the TypeScript class. In template-driven forms, you rely heavily on ngModule and directives in the HTML, which can make the template very cluttered and hard to read. With form group, I have complete programmatic control. I can dynamically add or remove form controls based on user input, which is a nightmare to do in template-driven forms. I can also create very complex cross-field validation logic. For example, making sure a confirm password field matches the password field much more easily in TypeScript. Plus, reactive forms are significantly easier to unit test. Since the form structure and validation are just TypeScript code, I can test the form's behavior without having to render the DOM or simulate clicks in a browser. It makes the data flow more predictable because it is immutable and flows in one direction from the class to the view.
Speaking of the template, you mentioned ngModule. For the sake of completeness, could you explain exactly what ngModule is used for?
ngModule is a directive used to create two-way data binding. It links a form element, like an input box, to a variable in the component class. This means if the user types something into the field, the variable in the TypeScript code updates automatically. Conversely, if the code updates the variable, maybe because of an API response, the text in the input field updates instantly. It basically saves the developer from having to write a manual event listener for every single input field to keep the UI and the data in sync.
Let's talk about structural directives. We use tarankan ng, if and tarankan ng for constantly. Could you explain what tarankan ng, if actually does under the hood? I'm specifically interested in how it differs from just hiding an element with CSS.
That is an important distinction. If you hide an element using CSS, like setting display, the element still exists in the document object model. It is still there, taking up memory, and any Angular directives or child components inside that element are still active and potentially running their own change detection cycles. ngIf is a structural directive, meaning it physically adds or removes the element from the DOM. When the condition evaluates to false, Angular completely removes the element. This means the component and all of its children are destroyed, and their onDestroy hooks are called. This is much better for performance, because you aren't keeping unnecessary components alive in the background.
Good. Now, let's imagine a scenario where you have a parent component, and it needs to communicate an event to several child components. But these children are deeply nested, maybe 3 or 4 levels down, and they aren't directly related to each other. What mechanism would you use to handle this, and why?
If I tried to use at input and at output for this, I would run into what we call prop drilling. I would have to pass the data through every single intermediate component, even those that don't care about the data, just to get it to the bottom child. It creates a maintenance nightmare and makes the components very tightly coupled. The most suitable mechanism here is a shared service using an observable pattern, again likely with a behavior subject or a subject. I would create a service that acts as a central event hub. The parent component pushes the event into the service. Any child component, no matter how deep it is in the hierarchy, can simply inject that service and subscribe to the stream. This allows for a one-to-many communication pattern that completely bypasses the component tree, keeping the intermediate components clean and focused only on their own responsibilities.
You've mentioned behavior subject and subject a few times now. To make sure we are fully aligned on RxJS, what about replay subject? How does that differ from a behavior subject, and when would you choose one over the other?
While a behavior subject only remembers the single most recent value, a replay subject can be configured to remember a specific number of previous values. When a new observer subscribes, the replay subject replays those last n values to them. I would choose a behavior subject when I need to know the current state of the app, like, is the user logged in? Or, what is the current theme? There is only one correct current value. I would choose a replay subject if I need a history of events. For example, if I have a notification system where a user might miss a few alerts while navigating, a A replay subject could allow them to see the last 5 notifications that occurred, even if they weren't on the notification screen when they happened.
That's a great example. Let's move to a more practical aspect of Angular development. Sometimes we need to step outside the Angular abstraction. How do you access the native DOM element of a directive or component if you absolutely have to?
To do that, I use the elementRef class. I inject elementRef into the constructor of the component or directive. This gives me an object that wraps the element. To get to the actual HTML element, I access the native element property. I do try to use this sparingly, because Angular is designed to be platform agnostic. If you write too much code that relies on native element, it makes the app harder to test and could potentially break if we ever moved to something like server-side rendering with Angular Universal. But for things like integrating a third-party JS library that requires a DOM reference, elementRef is the correct tool.
Fair enough. Let's talk about routing. In a single-page application, components are destroyed and recreated as the user moves around. How do you implement persistent data flow between different routed components so the user doesn't lose their progress?
Since components are transient during navigation, any state stored locally in the component is lost. To maintain data, I use a singleton service provided at the root level. Because it is a singleton, the service instance stays in memory for the entire duration of the session, regardless of which root is active. I would use a BehaviorSubject within that service to hold the state. When the user moves from root A to root B, component B can inject the service and immediately get the current state from the BehaviorSubject. This ensures a seamless experience where the user can navigate back and forth without the application resetting its state.
We've covered a lot of ground. To wrap up the technical part, I want to ask about your approach to services in general. What are Angular services typically used for, and how do you decide what goes in a component versus what goes in a service?
I follow a strict rule. Components should be lean. Their only job is to handle the user interface, the layout, and the interaction logic. They should be the view layer. Anything involving the business logic belongs in a service. This includes fetching data from a server via HTTP client, performing complex calculations, managing application state, or handling validation logic that is shared across multiple forms. By moving the heavy lifting into services, I make the code much more reusable. If I need the same data fetching logic in 3 different components, I only have to write and test it once in a service. It also makes the components much easier to read and maintain.
I appreciate the detail in your answers. You clearly have a strong grasp of the Angular ecosystem and a good sense of when to use specific patterns for performance and scalability. Before we finish, do you have any questions for me about the team or the project?
I do. You mentioned that you use WebSockets for some of your real-time lists. I am curious if you are using a custom wrapper for those sockets, or if you are integrating them directly with RxJS Observables to keep the data flow consistent with the rest of the Angular app.
That is a great question. We actually use a custom service that wraps the socket connection and exposes it as an observable. This allows us to use the same RxJS operators we use for HTTP calls, so the components don't even know they are talking to a socket, they just see a stream of data.
That sounds like a very clean implementation. I really like that approach.
Well, it's been a pleasure talking with you. We have a few more interviews to conduct, but we will get back to you by the end of the week with the next steps.
Sounds great. Thank you for your time. I look forward to hearing from you.